We're going to do have Inscribe Circle. We're going to use angle bisectors. And what do we call the angle bisectors? The special point that they form where all the angle bisectors intersect? That is called the incenter. Very good. The incenter. Okay? We've actually studied two different points of intersection in 6.2. There's the incenter where the angle bisectors intersect. And then if you turn that page over, look at the other side, there's the circumcenter where the perpendicular bisectors intersect. I got to be honest with you, when I was learning these terms, the easiest way for me to remember the difference between the two, the word perpendicular and the word circumcenter are longer words than the word angle and incenter. The shorter words go together. That's how I memorized them when I was first learning them. Now I usually just know them. However, I still fall back to those sometimes when I'm thinking of all the points of concurrency. So that's up to you. All right? Angle bisector. How do you construct an angle bisector? Talk about it with your groupies. Maybe show them how you do it on your paper. Angle bisector. You got 3 of them you have to do. Okay, volunteer. How do we construct an angle bisector? Yes, Sam? Yeah. Yep, the line will bisect the angle. Oh, let's start with that. Okay? Put our point on an angle and make an arc there. Okay, anyone remember what to do next? Carl? Yeah, let me label some things here. We'll call that A, we'll call this B, that point of intersection, that point of intersection C. So go for it now. That would be to reconstruct an angle. Good, but that's good memory about that. Yeah, Alex?
So, I don't know if this is right, but you draw a point, like a little curve from B.
Okay.
And then do from C where they intersect.
Good, yeah, you put your compass on point B. You draw a little arc there out in the middle of nowhere, and then do not change the setting and go to point C and make that same little mark. Okay, so where they intersect, you want to be pretty good with your measuring there. All right, where they intersect, that point, as well as point A there, if you draw a line through it, that is your angle bisector. Oh yeah, man, get the rulers. Rulers rule. All right, I want you to make 3 angle bisectors now. 1 from each angle in that triangle. Now the reality is once you have 2 angle bisectors done, where they intersect should be the incenter. The 3rd angle bisector is just to kind of make sure you got it right? That's kind of your check. But once you have it done, you should have a point in the middle, your incenter, which should be equidistant from where? What's it equidistant from? Yeah.
All the sides.
It's equidistant from all the sides. Okay? Yeah. No. It's going to be equidistant from the sides. The perpendicular bisector is equidistant from the angles. Okay? So, hopefully you get something that looks like that there. All right? Now, if we were to go from this angle out to a side at a right angle, so if I was just kind of sketching that, something like that, that distance right there should be equal, if I were to go out to this side at a right angle, to that distance, which should be equal to that distance out to that side at a right angle. That's what the in-center does there. And what that allows you to do then is, since those are equidistant, you can draw an inscribed circle. That means if you were to set your compass on that point, now I made that point pretty big, so I've got to kind of find the middle of that point, and then measure out to the edge of the triangle. Okay, it should hit the edge of the triangle there. It should hit again down here at where I had at the right angle, and then up there at that same right angle. Okay, so that should give you an inscribed circle that stays within that triangle. Oops. This compass is very hard to adjust. There we go. Paper just ripped. Unbelievable. All right. Check it out, man. So neato. Okay, equidistance from each side. So this little right angle marking, that's the radius of our circle. All radii are congruent. All right. How many got it? Okay. Hey, if you're still working on it, go ahead and set it aside for a minute. We'll come back to it. I want you to turn the paper over to the other side, and we're going to do circumscribed circles. A circumscribed circle means it goes around the outside. In order for it to go around the outside, it's got to hit, our circle has to hit all three of these points perfectly. So rather than the circle being inside hitting the sides perfectly, like our previous inscribed one, this one's going to go around the outside of the triangle. Okay, it's going to hit all three of these points equally. Which means in order to do that, to find a point that is equidistant from the three vertices, we have to use perpendicular bisectors to find the circumcenter. So, find a perpendicular bisector. How do we bisect a line using a compass? Let's say I label these points just so we can reference them. A, B, and C. Oh, we got two people? Talk with your neighbor real quick. How could we come up with a bisector? How could we cut this line or that line in half or this line in half using our compass? All right, what do we got? No one knows? That's tough, man. Only two people know. Same two people. Not that I don't want to call on them. Someone else take a shot. Anyone? All right. Go ahead. One of you guys. That's intense. All right. You win, Carlo. Go for it.
Okay. So you do the same thing what we did with points B and C when you were doing the angle bisector, except you just do point A and B, where you do it like, we have the thing fixed.
So set my point where?
So set the point thing on angle B or point B.
Okay.
And then you do like half a circle.
Okay, do like half a circle. So it's got to be opened up at least 2/3 the way or so. Okay.
Put it on C.
Okay, don't adjust it. Put it on C.
Do the same thing.
There we got it. Very good. All right. And then we draw a line using this and this. Well done. Okay. So that is going to give me my perpendicular bisector. Okay. It's at a right angle. This side is congruent to this side. If we call this D, CD would be congruent to BD. Okay. You may need to extend it out a little more. Remember, you're going to find out where all your perpendicular bisectors intersect. What's that? All right, so go ahead and construct 3 perpendicular bisectors there. Boy, it's kind of tough with these compasses. You really got to open them up. Barely reaches on that one. Remember, really after 2, you should have a pretty good idea of where it's going to be. That third one you construct is just to see if you're accurate. So once I have my 2 on there, this better be the circumcenter. We're hoping that we've done it correctly. That third one I construct is going to give me an idea if I did it correctly. It should hit that same point. It's kind of messy in there. Oh, it's really not a good one. Yeah, my last one there, I should have made some arcs further apart, but I was checking, so it looks like it's going to be accurate. So, all right, now remember this. If I were to draw a line from each of these angles, or from my circumcenter to each of these angles, that distance should be equal. All those distances should be the same. Okay, which means those are all what type of parts of our circle? What is this piece called? Yeah, that's the radius, man. That should be the same as that, which is the same as that. Draw our amazing circle. Hits all 3. Come on, that's Neato Burrito too. How do I draw perfect circles? Oh, I'm sorry. I thought you were just admiring the circle. I put my compass at the circumcenter, and then I open it up to the angles. They should all be equal distance away.